All right, this note is on the combined gas law. So essentially what we're doing in this case is we are taking all three of Boyle's law, Charles' law, and Gay-Lussac's laws and combining them into a single formula. And as a result, then we can compare pressure, volume, and temperature changes all at once. So rather than just looking at two, keeping one constant, we can actually change all three of them at the same time and see what we get. So as a result, we simply get P1 V1 over T1 equals P2 V2 over T2. All right, and that allows us to look for any single one, knowing what happens to the other ones. All right. So these types of questions look something like this. We have an aerosol can with a volume of 325 milliliters, contains a gas at 4.39 atmospheres and 12 degrees Celsius. What volume would the gas occupy if it was allowed to escape at 101 kilopascals and 21 degrees Celsius? Okay. All right, so let's go through and sort out the information first of all. So P1 we're given as 4.39 atmospheres. P2 is given as 101 kilopascals. Now I could have switched, taken the 101 kilopascals and converted it to atmospheres, but this time I decided to go from atmospheres to kilopascals. So converting the 4.39 atmospheres, we simply take the conversion. 101.3 kilopascals is 1 atmosphere. The atmospheres cancel and we're left with kilopascals. Okay, so 445 kilopascals is P1. Then we get the initial volume is 325 milliliters. The V2 is what we're going to be looking for. And T1, of course, we have to convert the 12 degrees to 285 Kelvin. And T2, converting the 21 degrees to 294 Kelvin. All right, now we go to our formula and we plug in our values. Again, notice that I've kept all of the units in just to make sure that I've got everything in the right place, because the temperature ones have to cancel, the pressure ones have to cancel, and the units for volume are going to be my final units for my final answer. Okay, so plug those numbers into the calculator, you work out and you get 1477.15 milliliters, which is roughly 1.5 liters, because over here we've got 2 sig digs for the 12 and 21 degrees Celsius. All right, again, it's fairly straightforward. So here's just a summary of those first three gas laws and the combined gas law. First of all, Boyle's law keeps temperature constant, so therefore it compares pressure and volume. Charles' law keeps pressure constant, so compares volume and temperature. Gay-Lussac's law keeps volume constant, and so compares pressure and temperature. And then finally, the combined gas law, there are no constants. All three things can be changed simultaneously. A good check if you're in doubt as to if you picked the right gas law or not is that if you use the combined gas law, then whichever one is being held constant will have the same value on both sides of the equation, and to simply drop out of the equation. So you can use that as a double check. All right, page 542, numbers 1 to 10 is your homework. Again, try those questions and then bring any questions you have as a result to class.